My name is Professor Christopher Crick. I run the Cognitive Robotics Lab here at Oklahoma State. And in this lab we do a lot of work having to do with robotic intelligence. We're interested in the basis for intelligence. Robots are great tools for exploring how humans develop, how biological intelligence works. And we also care a lot about leveraging intelligence in order to make robots better and more useful in the world. And as an example of the kind of tasks that we engage in the Cognitive Robotics Lab, one of the things we're working very hard at right now is human-robot teamwork. And you know about robots, you know that they exist out in the world now and people use them to do, you hear about drones, you hear about robots that go into the nuclear plant at Fukushima and look for problems and things like that. At the moment, though, all of these devices are basically just fancy remote control cars. Someone who is an expert has to sit down and devote all his attention to driving this thing around, and the robot is basically just responding to commands. Now, it would be nice if robots could be very intelligent and very autonomous, and you could just send a team of robots out to a disaster site, and they would know how to search for danger, know how to search for victims, cordon off the place, map the environment, and all of that. Well, we're a long way from having robots that can do that, of course. But we can't, we don't have the resources to support this kind of robot team with a bunch of people sitting at their consoles driving these things around. Yes, we can do that for 1 or 2 robots, but there's no reason in principle that we couldn't have 50 doing the work, except that we don't have people that are able to do this. You know, the humans at the scene are responsible for dealing with medical issues, dealing with the press, dealing, a disaster scene is a chaotic environment, and people have a lot on their mind. So if we could have robots that were able to act somewhat autonomously, that were able to go out and do the exploration and mapping, do the search and rescue, and do that under only occasional direction from humans, then we would be able to leverage a lot of power. And so one of the things we're working on is, well, how do robots talk to one another, and how do they talk to people? How do they jointly come up with plans? How do they communicate what they know about the world to their fellows? How does a flying robot meaningfully communicate information to a robot on the ground with entirely different sensors and entirely different actuators? How do little robots that can only scurry around exploring the environment, how do they tell big robots with arms that can actually move rubble and fallen beams out of the way what they know and how to do it? And how do these robots communicate information and solicit direction from their human teammates? Humans are busy. They have a limited amount of cognitive capacity to handle what the robots are telling them. There are emergencies that are popping up all over the place. And so a robot needs to be sensitive to the quality of information that a human is able to provide, how a human can give direction, and how do you represent a problem in a way that a human can quickly look at it and figure out how to solve it. How does a robot tell a human what it's found, what it wants to do, get confirmation, get further instruction, things like that. So our Cognitive Robotics Lab is working really hard at coming up with this sort of shared autonomy situation where robots and humans are cooperating with each other, acting autonomously when they can, doing the planning and decision-making to the extent that they're capable of, involving humans in the loop when necessary, and hopefully making the team much more successful than it could be with any one component alone.